In this video, we'll use the TI-84 and normal distributions to find values when we're given a percentage or a proportion. So our problem is the body temperature for healthy persons can be approximated by a normal distribution with a mean of 98.2 degrees Fahrenheit and a standard deviation of 0.65 degrees Fahrenheit. Part A asks what temperature would place a healthy person in the top 30% of temperatures. And Part B is what would be the highest temperature that would still place a person in the bottom 10% of temperatures. So what we want to do first is we want to draw a normal curve. We want to just sketch. You're not an artist. I'm not an artist, definitely. You can see that. And so we're going to draw the sketch. And remember that we have a situation where we have a normal distribution and a mean of 98.2 and a standard deviation of 0.65. So we will draw in our lines. We'll go out 2 standard deviations in either direction, and we'll label our mean as 98.2. And then we'll add 0.65 to the 98.2 and subtract 0.65. And we have to do it again, and we get out to 99.7 and down to 96.9. Segment farthest to the right, from 99.7 on theoretically to infinity, we have a small 2.5%. Between 98.85 and 99.7, we have 13.5% of our observations. And so somewhere between 98.2 and 98.85, we get this point, this temperature, where 30% of the temperatures, the persons with the top 30% of the temperatures, would be somewhere between 98.2 and 98.85. The command we're going to use is called inverse norm, INV norm, and what the syntax is that we take the area to the left, comma, and then the mean, comma, and then the standard deviation. So using the TI-84, we need to find the command inverse norm, and that's found under second vars, which is distribution. Since we're working with a normal distribution, that seems reasonable. We want number 3, inverse norm, enter, and then we want the area to the left. We're looking at the top, for the top 30%, the value that would place the normal healthy person in the top 30%. 30% would be 0.3, but that would be the top 30%, or area to the right. We need the area to the left, so we need 1 minus 0.3, which would be 0.7, and then you're going to enter your mean, which is 98.2, and then enter the standard deviation of 0.65. Close the parentheses, enter, and we end up with about 98.5 if we round it like our mean was rounded to the nearest tenth. Now we want to solve part B, which asks what would be the highest temperature that would still place a person in the bottom 10%. We're still using the same graph we used before, and if you refer back to that, you would see that between 96.9 and 97.55, somewhere in there we would have the bottom 10%, since by the time you got up to 97.55 you would have covered 16% of your values. Now we need to do part B, and we are going to use the same command, so we can press second, enter, which would be entry, arrow up and arrow across to 1.1, which is 10%, to the left of the value we want, and use the same mean and the standard deviation. Press enter from anywhere on the line, and we find that the temperature, the highest temperature that would still place a person in the bottom 10% of temperatures is 97.4.